Good morning. Happy Wednesday to everybody. First virtual day when most everybody was in school on Monday and Tuesday, and then most everybody comes back tomorrow, which is kind of nice. So we're going to go over a few questions today from the homework. I have one review summary problem that I want to do as an opener, which we'll do after the homework. So it'll be a post homework opener. And then we are going to review for your quiz tomorrow on section 7.1 to 7.3. So there is a review worksheet that will be posted for that quiz tomorrow. A few reminders besides taking the quiz tomorrow. Chapter 6 test corrections. I know some of you did submit them last evening or early this morning. They are due tonight. So if you are interested in taking one of the portions of the Chapter 6 test, retest, make sure you do submit that tonight. And you can do one portion or you can do both. It's totally up to you. But if you weren't happy with your score on part 2 or you weren't happy with your score on part 1, then make sure you do the test corrections and the practice problems from either of those two parts or both of them. And then I'll schedule a time with you to retake the test via Zoom, or if you're in school, we can do it in the morning during homeroom when you get there in the morning, or we can figure out a different time to do that during the school day. So we are going to go directly into the homework. I'm going to start first with number 11 from the book, and then I wanted to do number 13 from the worksheet. So we're going to start with the book and look at number 11. The first group of problems in the book that you were assigned asked you to simplify the expression involving an E. And this one, again, number 11 from the book, says 3e, and then you're dividing that by e to the x. So, Jaden, when you are dividing, what do you usually do with the exponents when you're dividing?
You would subtract them.
Yeah, what's the exponent of the e in the numerator?
1.
A 1, yeah.
1, yeah.
It's a 1. So we are going to subtract them because that's how you condense or pull together exponents. So the 3 is the coefficient. It doesn't have anything to combine with. It's just going to stay as 3. And then we are pulling those exponents together, or the e's together, by subtracting the exponents. So the exponent of the numerator is a 1. You're subtracting the exponent of the denominator. So that would be stay as 3, and then we have e, and then it's just 1 minus x. And you cannot simplify that any further because you cannot combine the 1 and the x together. But you are subtracting the exponents, showing that those e's do combine and simplify. So 3 times e, and then the 1 minus x as the exponent. Any questions on that? Again, number 11 from the book. All right, so going to the worksheet, number 11 and 13 on the worksheet were similar, and I thought we would go over 13 because it's a 2-part problem. And this is a nice summary to kind of prepare for reviewing today. You deposit $2,200 in an account that pays 3% annual interest. After 15 years, you withdraw the money. What is the balance if the interest is compounded quarterly? So when you're looking at these problems, the most important part of the problem is to see how it's compounded, because that determines the formula that you're going to use. So in part A, it says the balance is compounded quarterly. So when we're talking about it being compounded quarterly, there's a different formula than if it's compounded continuously. So 2 different formulas. Continuously is the formula we talked about yesterday. Quarterly is the formula we talked about in section 7.1. Gabby Soul, do you remember what the formula is if it's compounded quarterly or monthly or daily?
Um, would it be PERT?
That would be if it's continuously. So that's our PERT formula.
Okay.
What was the other
Then
formula?
would it be like the R over N?
Yes, yeah. So we have the P, 1 plus R over N, and then the exponent is N times T. So there is a difference between the two formulas. So PERT is when it's compounded continuously. The reason we use the PERT formula for compounded continuously is because that's how the number E was created. So it was actually created from this first original formula, except the N was a really big number. And we saw that how it worked on Monday. So the E was created from the formula in part A, but we use the E because that represents a continuous compounding. So the goal here is kind of just to see what the difference is in the amount of money that you would have after 15 years. So we have $2,200 you're investing. The rate is 3%, which is 0.03. Quarterly means 4 times a year. And then the exponent is 4 and then 15 years. So that would be plugging it into the first formula, compounding continuously. The second formula, the first formula compounded quarterly. The second formula for continuously, Gabby said that's the PERT formula. So we still have 2,200 bucks. But we have the base E. The rate is still 0.03 and the time is still 15. So that would be the difference of the two formulas. So one formula representing a different number of compoundings a year, and the second one only being used when it says compounded continuously. And then when you plug the first one in the calculator, you end up with $3,444.50. Not bad. You started out with $2,200. 15 years later, you have about $1,250 more, which is pretty good just by investing your amount. The second one, when you use the PERT formula, you end up with $3,450.29. So the goal is for you to see the difference, and you have more money when it's compounded more times. And that's because you're earning money, and after you earn money, you get interest on that extra money that you earned. So that's how interest works. So at the end of the month, I have a new amount of interest. So the next month, then my interest is based on that larger amount. So every time you're earning interest, you're also gaining extra money as well. Questions on 13? Or the difference between the two formulas? So I had this problem on there so you could see the difference between the two formulas, why you need to use one formula versus the other. Are there any questions? All right, so what I'd like you to do is to go to Google Classroom. And on Google Classroom, I would like you to pull up the warm-up review for today. So if you could do that for me. Talks about the population in California. And it should say opener review section 7.1 to 7.3. It's the first thing posted in your stream. It is already posted there. You will need a calculator, so if you don't have one, grab that calculator. So, sunny California. The population from 2000 to 2010 increased at an exponential rate. So that means the rate's growing at a pretty quick manner. It's not growing linearly. So they're not increasing by 100 people each year. Maybe one year it's 100, and then the next year maybe it's, I don't know, up to 500, and then maybe it's up to 1100. So they're increasing at a rate, but that rate is getting more and more each year. In 2000, the population was 33,871,648. The next year, 1 year later, it's increased to 34,479,458. So that's a pretty big increase from 1 year to the next. The first question says, what is the growth factor? Round to the nearest thousandth. So in most of the questions we've done, you are given the rate of growth. Usually it says it's increasing by a rate of blank, and it says 2%, 5%, 1.5%, but it gives you the percentage. In this case, we don't have the percentage. We need to find out what the growth factor is. And there's a really easy way we can figure out what the growth factor is using those two numbers. Does anybody have an idea how we can find the growth factor? So think about how would those two numbers help us find the growth factor? Jaden, what do you think?
Would you divide them to figure out like what you increased by?
Yeah, exactly. So we're going to figure out what we increased by. And as she said, you're going to divide those. And that's going to be then your growth factor. How much did you grow from 1 year to the next? Now, the year that goes on the top of the fraction would be the current year. So the current year would be 2001. The year that goes on the bottom is the previous year. Because we're growing, we're increasing, time is moving on. So I'm comparing the current year to the year before it to get this growth factor. Or it might be a decay factor if the number on top is smaller. But make sure that you are using the current year divided by the previous year. So we're talking about 2001 compared to 2000. And Jaden, what number did you get there to the nearest thousandth?
Sorry, give me 1 second. I'm still
Nope.
plugging it in here.
There's a lot of numbers to plug in.
I got 1.018.
Yeah. So when we're talking about an exponential growth function, that number has to be bigger than 1, which it is, so we know it grows. There were two different functions that we talked about, a growth and a decay, but for it to grow, we use the model y equals a, and then 1 plus r to the t. The quantity inside is the growth factor. So that 1.018 represents the quantity inside. So that is our growth factor. Part B says, what is the annual percent increase? Well, that would be the R inside and just the R. So there's a difference between the growth factor and the annual percent increase. So the percent increase would be the R value, but we need to write it as a percentage since it says percent increase. So my entire quantity inside is 1.018, but that represents 1 plus R because that's my growth factor. So my R value is 1.018. I'm sorry, I can subtract the 1. How about 0.018? So Ava R, as a percentage, what is 0.018? What would be our rate as a percentage?
1.8%.
Excellent, 1.8%. Questions on the difference between the two, part A versus part B. So we found the growth factor by dividing the two values. If that number was less than 1, then it would be a decay factor. And then we could find the rate by just subtracting 1 from that, because that growth factor represents 1 plus the rate. So I would just subtract 1 from that value. Part C says write an exponential function that models the population where t is the number of years since the year 2000. So to write that exponential function, we start with A, the initial amount, and that initial amount was in the year 2000. Then we have our growth factor, which we already calculated in part A, and then we have our exponent. So the initial amount, the growth factor, and then the exponent of t representing the number of years. And then finally, for part D, estimate the population in 2017. So Brooke, what number are we going to plug in for the time in 2017?
17.
Yeah, 17 years past 2000. So just be careful. I know there's a lot of numbers here. And then you're plugging in the exponent of 17. Brooke, can you tell me what you have after you plug that in your calculator?
Um, 45,872,092.
Nice job. Is there anything after the 92?
Yeah, there's a bunch of decimals.
Okay, what is is the decimal bigger than 5?
Yeah, it's 7.
7? All right, so let's make that 92. We'll bump it up to 93. Nice job reading that big number too, Brooke. So make sure you label it with people. We're talking about the population in California. When you talk about the population of California, we're talking about the people in California. And this number is actually higher in 2017. The actual, I looked it up just so that we could see how close it was. The actual was 39,600,000 approximately. So at some point, this equation then changed. So, and you can see that the numbers are good in this equation from 2000 to 2010. So at some point, the population then wasn't increasing quite as much, and we would have to then change our equation to manipulate it to model the new increase of population. Are there questions? So there is a problem like this on your review worksheet, and we can go right back to Google Classroom one more time here, and we'll open up the review worksheet. So it should be posted for you on Google Classroom. Can you give me a thumbs up when you have it pulled up? Awesome, thank you. So just looking through the worksheet, you can see the first 3 questions deal with exponential growth and decay functions. The first one is a growth function because the value is bigger than 1. I can see the second one is going to decay because 2/3 is less than 1. And then the last one contains the E. So you have one of each. If there is a translation, you must graph two functions. So looking at numbers 1 and 2, there is a translation anytime there is a value being added or subtracted. So you must graph the original function and then I want to see the second function as the translation. Also, a lot of you still aren't graphing the asymptote. Make sure you graph the asymptote. If it's not graphed, it's not a complete graph. So make sure you're graphing in that horizontal dashed line. Where is the asymptote of the equation? So please remind yourself to graph the asymptote. And then there are some word problems on here, actually a bunch of word problems, just going over the various word problems that we've discussed. But numbers 10 through 12 would be similar to the problem that we just did. So 10 through 12, you're going to calculate the growth or decay factor. And then you'll answer the questions. But 10 through 12 are just like the problem we went over. And then it ends with some simplifying. So I'm going to give you the remaining 20 minutes of class to work on this. If you want to remain on, feel free to do so. You don't have to stay on though. I will be here if you have questions and you want to come back into the Zoom. So feel free to rejoin the Zoom. Tomorrow morning, for those of you that are in the classroom, please ask questions when you come to school. That's the whole goal. You're in my room for homeroom. You get there early. Ask any questions that you have about this review worksheet so that I can answer them while you're in the classroom. If you're at home, join Zoom early if you have questions and I will let you in and I will answer any questions that you have. For those of you at home, your test will look a little different. There is going to be a statement listed above, and that statement is one that you will verify saying, I'm not using my notes, I'm not using the internet, I'm not using any other device to help me on this test. And you must sign that in order to complete the test. So yours is going to be different than the ones in school. In school, you'll be taking a paper test. I will no longer be giving tests on the iPad. So it'll be a paper. Make sure you have a pencil to write with. Any questions? Have a fantastic day. It's going to be a beautiful day. So make sure you get out at some point today, get outside in that sun. Have a great day.
Thank you. Have a great day.
Thanks. You too. See you, Ava.